So now we're going to talk about what's called the slope-intercept form of an equation. So we've learned that it's helpful in some cases to write our equation so that we have y by itself and we have some number times x plus some number on the other side. We called this solving for y in terms of x. Well, there's another name for the form of equation where y is by itself and everything else is on the other side, and this is called the slope-intercept form of an equation. And this is for linear equations. So this is for linear equations when x, and that means that x does not have an exponent and x is not in the square root or cubed root or some kind of root. So whenever you have y equals a number times x to the first power plus some constant, this is called the slope-intercept form of an equation. So we describe this equation with an m and a b. So do you remember what m stands for? M is slope. And we're going to let b stand for what's called the y-intercept. What is the y-intercept? Do you remember? It's where our line crosses the y-axis. So when solving for y in terms of x, your equation is set up in slope-intercept form. This allows you to graph very quickly. So once you identify the slope, which is that m, and once you identify the y-intercept, which is that b, you can graph very, very quickly. So let's look at an example. So the first thing I want to do whenever I have an equation that is linear, and again, I know it's linear if the y has a 1 as an exponent and the x has a 1 as an exponent. If I have a linear equation, the fastest way to graph it is to put it in slope-intercept form. So that means I'm going to solve for y in terms of x. So I'm going to go ahead and solve this equation for y in terms of x. So I'm going to add 2x to both sides and then divide by 3. And when I do, I find that this is my equation, y equals 2/3 x plus 3. So I've solved for y in terms of x, which is the same thing as writing my equation in slope-intercept form. So here's my slope, m, and here's my y-intercept, b. Again, this is the basic form of your slope-intercept equation. So now I'm going to start by graphing this equation according to b, the slope, or the y-intercept rather. So I'm going to start by graphing the y-intercept. So what does that mean? We're going to put a point where 3 is on the y-axis. 3 is my y-intercept, therefore the ordered pair is 0, 3. So I'm putting a point at the ordered pair 0, 3. Now I'm going to use my slope of 2/3 and work with rise over run. So I'm going to rise 2, 1, 2, and run positive 3, 1, 2, 3. Now I like to go back, now I could keep going, 1, 2, 1, 2, 3. So I could keep going in the direction to the right, or I can go back to the original point at 0, 3 and go down 2. So remember, the slope is also negative 2 over negative 3. So I can go down 2 and over 3 in the negative direction, and that will work. 1, 2, 1, 2, 3. Now I just connect all these dots. Connect the dots, nice and easy. So my ordered pairs form a line for the equation y equals 2/3 x plus 3. Go ahead and try this next equation. First, you're going to want to put this in slope-intercept form by solving for y in terms of x, and then graph it. Remember, when you start graphing, you start with your slope, and then, you start with your y-intercept. Remember, when you start graphing, start with your y-intercept, and then from that point, use your slope to find your rise over run. You'll want to have 3 points. Go ahead and graph this with a minimum of 3 points. And try working with your slope so that you have the slope going up in one direction and down in the other, or up in one direction and down in the other, depending on if you have a positive or negative slope. That way you can practice working with your slope the two different ways, like I just showed you, with negative 2 over 3 and positive 2 over 3, so you get comfortable with that. So I ended up with the equation y equals 5 halves x plus negative 5. And I started by graphing my y-intercept at negative 5, and then I rose 5 and did a positive run of 2 to end up on 2, 0. And then I went back to my y-intercept of 0, negative 5, and I went down 5 and over 2 in the negative direction. So my slope is both 5 halves and negative 5 over negative 2. Now, I want you to double check whenever you graph and make sure that you have at least the correct sign on your slope. So when I get 5 halves as my slope, I know I have a positive slope. And keep in mind that little v I was telling you about. This is the positive slope, and this is rising in a positive direction, so I know I at least have that much correct. Go ahead and complete this next problem. Put it in slope-intercept form and graph using the y-intercept and slope. Here is the solution. There are 3 points, and keep in mind that the 3 ordered pairs I come up with when I graph, when substituted in for x and y in my equation, will make it a true statement. Go ahead and try this problem. So here's my equation written in slope-intercept form along with the graph, and I worked with my slope equaling negative 2/3, and I also worked with my slope equaling 2 over negative 3, since they're the same thing. And of course my y-intercept was negative 2, or the ordered pair 0, negative 2, which is where I started graphing from. Now let's do a quick recap. There are 3 methods for graphing an equation. The first one we learned is to make a table. And making a table, I call it an XY table, but making a table is great because it works with all types of graphs. So remember, we did some that were really funky, like y equals x squared plus x minus 5. We can graph anything. This is not a linear equation. This was actually a type of parabola. But you can graph anything with a table. And that's why it's important to know how to use tables. And then standard form with x and y intercepts. This works for anything that crosses the x and y axis. Not all lines or graphs are going to cross the x and y axis, but many of them do, so it can be very helpful. And then we just learned how to graph using the y-intercept and slope with the slope-intercept form of an equation, and this works with lines, with linear equations. So keep in mind one tip with using the slope-intercept form of an equation. What if I end up with y equals 2? Or for any of these techniques, y equals 2, what does that look like? It's a horizontal line and it intercepts 0, 2. What about x equals negative 4? It's a vertical line that intercepts negative 4, 0. What is the slope on y equals 2? This is a 0 slope, right? Because if you were rollerblading, you wouldn't go anywhere, but you could stand on it. What about x equals negative 4? What kind of slope is that? It's infinite, or undefined slope. Again, with the rollerblade example, it's impossible to rollerblade down a straight line.